Hey guys, Mrs. Butaki here. Today's video will be on foiling, and I know we've done this 100,000 times, but it never hurts to review it, especially in this chapter. When we're dealing with quadratics, they could be in any type of form, standard form, where you have to FOIL them, where you have to factor them. So let's take a look at some foiling examples. If you recall, foiling first, outer, inner, and last that each letter represents. So let's look at an example. You'll see what I mean. Let's say I have x plus 3, x minus 5. First thing I'm going to do, multiply my first two terms together. So x is my first term here, x is my first term here. I will multiply them together to get x squared. Next, I will look at my outer terms. My outer terms would be x and negative 5. And I will multiply the two together to get negative 5x. Don't forget that negative sign. Then I'm going to look at my inner two terms, which would be 3 and x. And that gives me a positive 3x. And then finally, my last terms would be 3 and negative 5, which would give me a negative 15. Okay, am I done? No. Let's reduce, or combine rather. So we have an x squared, negative 5x plus 3x is a minus 2x minus 15. And then we're done. Okay, so this is a quadratic in standard form. Where A is my x, my first term, my x squared term, which would be 1. B is my second term, which would be negative 2. And C is my third term, my constant, which is negative 15. Okay, let's try another one. Okay, my expression, x plus 2 times the quantity x minus 2. Let's use our foiling method. My first terms are x and x. That gives me x squared. My outer terms, rather, would be x and negative 2 minus 2x. Inner two terms, 2 and x. That gives me plus 2x. And outer two terms are positive 2 and negative 2. Multiplying them together gives me negative 4. Okay, so let's combine some terms. I have a positive 2x and a negative 2x, which gives me x squared minus 4. Okay? This is my quadratic. Notice when you have the same initial term and the same constant, only with different signs, that's called the difference, or rather, well, it's a perfect square, we'll say. Perfect square. Okay, we'll get into that later, but know that your middle terms will cancel out when it's in this type of format. So what does this look like graphically real quick? I'll just kind of make a little graph, a little sketch here. Okay, graphically, if I say we have y is equal to x squared minus 4, what's going to be my vertex? Okay, where is it going to cross the y-axis? And what is my axis of symmetry? So my axis of symmetry happens at negative b over 2a. Do I have a b term? No. I have an a term. My b term would be something with x attached to it, and then my c term here is my constant. I don't have a b term. So we would assume it's 0. So 0 over anything is 0. So my axis of symmetry is 0. So I'm going to make that right here, which also acts as my x term for my vertex. Okay. When I plug in 0 for x squared, or 0 squared rather, is 0, minus 4 is negative 4. My y value is negative 4. and that is my vertex. And we have just a rough sketch of our parabola. Just a little side note there. Okay guys, that's it for this video. Foiling, you've done it in a few classes now, and you should be good to go. We'll do more in class. Have a good one.